During a collision or an explosion in an isolated system, measurements confirm that the total momentum doesn't change. If you look here at the diagram on the left, we see two objects approaching each other, colliding and coming apart. What's important at this point is to note that the velocities prior to the collision are marked simply with a subscript denoting the object itself, and after the collision they have a subscript denoting the object, but also a prime, an apostrophe next to it, which denotes the velocity afterwards. So as we work from here, you will see equations that look a lot like this, where we see the sum of the momenta before collision. Here we don't see the prime on the velocities, and after the collision, where we see primes on each. Our first application of conservation of momentum is explosions. In an explosion, one object breaks apart into two or more pieces, or objects that are stuck together and moving together break apart, moving afterwards as separate objects. We'll assume two things. One, that the object or a coupled pair of objects break apart into two pieces, and that the explosion is along the same lines as the initial velocity. We look at conservation of momentum problems in the following way. We always have two diagrams, one before and another one after. In this particular example, we see two objects coupled together moving to the right. Afterwards, they've broken apart, and you see them moving away from each other. But one thing to note, the total momentum is conserved, so as a pair, they're still moving to the right. It's just that they're moving away from each other. We use these diagrams to lay out equations that will help us find any missing information about velocities before or after. So in this first case, in the before side, we have the momentum of particle A and the momentum of particle B summed together, and here we see the momenta of the respective objects after, with a prime to indicate that these are the momenta after the event. If we look at these more carefully, we can see that before we have two masses coupled together, acting as a single mass, moving with a single velocity. So we write that the sum of the momenta before is just mass sub A plus mass sub B times their common velocity v. After the explosion, we see two different objects, each with their own mass and each with their own velocity. So the final momentum is m sub A times v sub A prime plus m sub B v sub B prime. Remember, the prime is always used to indicate the velocities after the event.